All right, so today we're going to talk topic 5, data cleaning in pandas. Basically more pandas methods that we're going to talk through. But before that, I wanted to talk about the assignment that I sent out to you all. So I've paired you all up. The pairs are up on Slack if anyone has any questions about that, or if anyone can't get a hold of the project partner, please let me know by end of today. You should reach out to your project partner by the end of today, set up a time to meet and work through it together. Just to walk you all through, the cumulative labs are under, let's see. Yeah, they're under topic 4, EDA with pandas. I believe this is like a housing data set. And then also under topic 5, pandas data cleaning. So it's up to you to decide which one you want to work on. Topic 4 is on housing data. Topic 5 is on superheroes. So up to you to decide. It doesn't matter which one you choose, just pick one. And then I've thrown some more instructions on the homeroom here. Roughly, this should not take more than 3 to 4 hours. For both of them, there are some more open-ended sections. Feel free to put as much or as little work you want to put into that. Some students really like take the ball and run with it and do really in-depth great work, but also I know that there's a project that's coming up. So up to you to decide how much work you want to put in. In terms of deadline, I will say end of the week, but I'm also going to tell you that I'm not going to look at it until next week. So feel free to take the weekend if you want to. If you don't want to work over the weekend, which I do recommend, I don't want to give y'all like weekend homework. So you don't have to work on it over the weekend. So I'm not going to look at it till Tuesday because Monday's a holiday. But yeah, I do recommend try to finish it out by Friday so you don't have extra work. In terms of how you submit it, just Slack over your notebook. So if you decide to clone it down and work together, you can do that. Or if you're working on it on Illumidesk, one way you can do that is in Illumidesk. So let's say you're working in the lab here. You can actually download your notebook file. So the way you do that is, while it loads, when you're done with your work, you click onto File, Download as IPYNB. This will download a notebook file into your computer, and you can just drag and drop that into Slack and send it over to me. So that's how you submit. If anyone has any questions about that, let me know. If I don't receive a submission by you by like Tuesday morning, I will Slack you and look for it. Any questions on that? Cool. Well, so just remember, you only need to pick one, either topic 4 or 5. And both are kind of open-ended at the very end, so it's up to you how in-depth you want to go. For me, the main purpose of me seeing your work is to just get a sense of how you or your partner code. In terms of collaboration, because we haven't really talked about how you share work yet, several ways you can go about this. You can send each other notebook file back and forth. You can do that. You can also just have one person code and the other, maybe you're talking through the problem. Really up to you. I'm going to talk more in depth about collaboration techniques as we get into the phase 1 project. So I'll talk about that then. But yeah, questions about that assignment? All right. Next thing, I wanted to kind of talk about the upcoming project. So again, I'm going to show you all the calendar. I'm going to introduce the project June 1st. So that project will be introduced on June 1st, but you won't be presenting the project until June 11th. More about that then. Why I bring up the project now is because if you take a look at Canvas, the project is actually there for you to take a look at if you want to. Also, I talk about that today because after today's topic, after topic 5, you can pretty much work on the project already. So if you want to get like a head start, if you want to just like explore what the project's about in preparation for next week, feel free to do that. Do keep in mind that I will be pairing you up with different people for this end of phase project. So just, yeah, do whatever you want with that piece of information. I will get way more into the details of this end of phase 1 project next week though. But yes, any questions about any of that stuff at this point? Awesome. With that, let's dive into pandas. So today we're going to go over 4 of the main parts of pandas. Map and apply, which is basically how you can broadcast functions across your pandas data frames. We're going to talk about group by, joining data frames, as well as how to deal with missing values. So these are the 4 main things we're going to be talking about. So to start, map and apply. This is where lambdas come back into play. I think that if you're using map and apply, is a really good idea to make use of lambdas, especially if you want to do like slightly more complicated functions on your data frame. So to start, let's import our go-to libraries. Usually NumPy and Pandas always comes together. And we are going to use the same data set that we talked about yesterday. Well, we didn't really talk about it, we imported it yesterday. So we're going to use this car data frame where this is miles per gallon, cylinders, all these other things about cars, a car name. And if we remember, .describe is a really good one to quickly inspect your data frame. Another good one to always use is .info. So here you can see that we do not have many missing values, but we have a bunch of different data types. Cool. So let's start with map and apply. I guess before getting into that, I want to talk about Boolean masking, which is kind of very similar to what we talked about with broadcasting yesterday. So let's just say, let's see, we have our model year column here. And right now it's all in like 2-digit numbers, which as you can guess, it can get kind of problematic if you have cars that span over more than a century. So just really quickly, let's take a look at how we can just add like 1900 to each number. Because Pandas supports the broadcasting functionality that NumPy has, this becomes very, very easy because we can just do cardf year, which is the series. So cardf year, which will give you, model year, sorry. I have to change all of those later. Model year gives you this series over here. Another syntax you can do, if it wasn't a space, and I'll show an example with origin. If it didn't have a space in the name, a different syntax, you could do origin like that. Exactly the same thing, but we're going to do model year, which has a space in its name, so you can't do that. So we have this, and we can broadcast plus 1900 across that entire series, which is great. So model year again. Okay. So great. Now it's more clear exactly what year these cars were made. One other thing to talk about is that this is not a destructive method. We talked about destructive versus not destructive methods when we talked about, I think, Python basics last week. So if you want to fully edit your data frame, see if we rerun this again, the model year is still at 70. We would have to reassign it. So we would have to reassign cardf model year is equal to cardf model year plus 1900. So after this is done, we take a look at cardf model year has not been, I added a underscore. But if we had it like this, you'll see that it overwrites. There we go. So now has model year here. If it sees a key that it hasn't seen before, it'll add a new column. So maybe I want to have one version with the 19 and one version without. You could do that too. But this is actually potentially really confusing. So we can actually drop that. A quick syntax to drop a column is like this. So let's reassign cardf. And with that, we can see that cardf has dropped that column. Cool, just so it doesn't distract us. Okay, so that just shows that if you want to do something very, very simple, a very simple operation for like an entire column of your data frame, broadcasting works. Boolean masking is another thing. We sort of talked about this yesterday. Boolean masking basically broadcasts a condition over a series or an entire data frame or part of a data frame even. So let's just take a look at these three columns first: miles per gallon, cylinders, displacement. as a very simple example, let's just see which ones are even numbers. So if I add this condition back here of like modulo 2 double equal to 0, you can see that we end up with a bunch of trues and falses, depending on where the condition is true or false. Which ones are even, which ones are odd. So this is Boolean masking, where you're basically broadcasting a condition such that each value becomes a true or false. Very, very neat, very, very helpful. Same thing for here. If I just want to find like heavy cars, I can just maybe look for weight above 2,800. You can see it's a bunch of trues, a bunch of falses. If you want to create a new column with the result of a Boolean mask, it's actually pretty simple as well. I'm just copy and pasting car df weight greater than 2,800. Let's just say I want to have a column called heavy, and we'll take a look to see what this yields. If I assign heavy to this series of trues and falses, if I look at my car df now, there is another column of whether the car is heavy or not. Actually, let's take a look at a bigger output. You can see that I have a new column with trues and falses of whether the car is heavy or not, which is a result of us Boolean masking the weight column. So you can basically create a bunch of new columns this way. This is known as feature engineering whenever you're making a new column out of another column or a combination of columns. That's known as feature engineering. It's actually very, very powerful. That whole concept and field of feature engineering, really, really important for later in the program. But we just feature engineered a heavy feature, whether the car is true or false, based on Boolean masking the weight column. Cool. With that, let's talk about maps and applies. So within Pandas, there are 2, 3, 2.5 methods that allow you to perform functions over your data frame. So there's map, which I'm going to talk about first. There's apply, which is very similar but slightly different. And then there's apply map. So I'll talk about all of these, but let's start with map, because map is the easiest one. So the map function, and when you use a map function, only works on series or on single columns. So if you only are doing something on one column, you can use .map. So we can actually do something that's very, very similar to what we did before with Boolean masking. So this is where we make use of lambda. And I know I need to change this from year to model year. Sorry about this if you've downloaded this notebook and you have to make all these changes as well. But let's take model year. Let me just comment this part out first so it's not distracting. So we have model year here. What we're going to do is we're going to use a lambda to map a condition. Exactly the same thing as Boolean masking, but this is a very simple example to show. We'll get more complicated in a little bit. But we're going to map this lambda function. So this lambda y is going to look for y less than 1980. What this is doing, this y is basically going to refer to every value in model year here and broadcast the condition of whether it's less than 1980 or not. So when we run this, we get trues and falses. And if you want to save this, we can maybe do something like car df, maybe like older car as an example, older car equal to, copy and paste this, and let's just look at car df afterwards. We will have this true false based on whether it's an older car or not. So very, very simple lambda. Of course, you can argue that for something like this, we can pretty much do this as well, but just to show how the lambda works. Each y, or here you can pretty much use any letter you want. Y, I guess in this case, stands for year, but you can use whatever letter you want, but each lambda variable is going to point to every value in your series here. Okay, so let's get a little bit more complicated. Let's look for the car name. So car names, you can see it's not very clear which part is the brand, which part is the make, the model, I don't know. So let's do something about the name. So car name, it's called car name. Okay, so car name here, you have a bunch of these car names. Let's maybe do something that looks for all the Fords in our data set. So what we can do here, we can use very, very similarly, check for if Ford is in N. So in this case, we're looking through car name. And let me just edit this real quick here first. Lambda N means that each N is going to point to every car name here. And we're just going to see if the word Ford is part of the string of the name. So once we do this and run this, you can see that, okay, cool, there's a bunch of trues and falses. Like 4 comes out to be true, and turns out, yes, 4 is a Ford. Trues for 390 and 387. You can see that Ford Ranger is here. Ford Mustang is here as well. So great, these are Fords. So maybe in this case, we want to save whether the car is a Ford or not. So if we do cardf Ford, perhaps, we can assign it to the result of this map. And let's take a look at our cardf now. Cool, so we will get a bunch of true falses based on whether something is a Ford or not. So these are fairly simple lambdas. We're going to get into something more complicated, but one quick tangent. There's a couple methods that I want to show you all as well that are very, very useful. Unique and value counts. These are ones that I also use pretty often to inspect my data. And these all work on series. So these only work on single columns. So value counts will basically give you value counts. So in this data set, there are 5 Ford Pintos, 5 AMC Matadors, 1 Volkswagen Jetta, so on and so forth. You can also see the unique values. Unique values, they basically give you a list of all of the unique values in here. You can see there's a bunch. And there's also n unique, which will tell you the number of unique values, basically equivalent to finding the length of the result of unique, but sometimes this is just quicker. Number of unique values, there are 301 different car names within these 392 rows. Whatever you do with that information, whatever you want to do. But yeah, just wanted a quick segue to mention these methods. All right. So let's talk about a more complicated lambda. We kind of talked about this on, I think, yeah, on Friday, how with lambdas, you can actually feed it in more complicated functions. So let's do that. Because in map, you know that whatever variable you put here will refer to each value. When you're defining a function, remember that the input for your function should be a value. So let's take a look at this function real quick. This is just a fairly simple like if-else function to basically check for several car brands. This one is just going to look for Fords, Buicks, Chevys, and other. And to note, the input of this function is a single value, not an entire series, but a single value. Let's run this. And now that I have this car brand checker, we can actually check if this works. So let's do car brand, and let's just do like a random string. Other should come up, which is correct. Now let's look for, let's see, Ford Torino as an example. Ford Torino. Cool, and it comes out as Ford. So we know that this function does work. Great. Let's map this function, broadcast this function onto our car name column. So what we do is we do car name dot map lambda n car brand n, because we're broadcasting the car brand function onto each value in car name. So when we do that, we'll see that our resulting series has Chevrolet, Buick, other, blah, blah, blah. We can actually stack methods. If you remember that, we can do a quick value counts. And you can see that 284 others, 48 Fords, 43 Chevys, 17 Buicks. Cool, good to know. And let's just assume that this was just way more comprehensive. We can actually make a brand column. So cardf brand equal to this. And then now, when we look at cardf, we will have a brand column. That is a result of us mapping this car brand function onto the car name column. Any questions at this point? Awesome. Just remember that map only works on single columns. So anytime we use like a dot map, it was always on a series. So remember that. If you want to work on multiple columns, we want to move over to the apply function. But before I get into apply function, I want to show you all that this other function called apply map exists. Apply map, very, very specific, but apply map applies a singular function to the entire data frame. Apply map is not very often used, but I just wanted to mention just in case you probably come across it in documentation. But apply map will work on any data frame object. And remember, if you have a subset of a data frame that is more than one column, the data type is still a data frame. So here, just an example, what will work is cardf.apply map. Same thing. It works with lambda, and the value will actually point to every single value in this entire table. So let's just say I want to like coalesce everything into a string, even my number variables. This is not super clear, but you can see that if I do dot info, everything has become an object data type. And in data frames, objects are strings. So everything has been already turned into a string. Just to show that this works on subsets, if you want to get a subset of multiple columns, you can do like miles per gallon. You could do, let's see, weight, maybe another one like origin. You can apply map onto a subset like that. This is all strings. If we take a look at the dot info, these are all strings. But again, not destructive until you reassign it to the variable. So basically, the cardf has not been changed. So I take a look at cardf.info. It is still our one with all the numbers. Great. But if I did want to keep these changes, I can either save this into cardf2 or save it as something else. So, oops, I don't want to save it as .info. I want to save it as this, and then I'll have my cardf2 being this with all the strings. So .info will show that these are all the strings. So remember that a lot of these methods are not destructive. Okay, so that was a little aside. Back to apply. So apply allows us to perform specific functions that take in different columns as inputs. I will tell you as well that if you replace this .map with apply, it will also work. So apply is actually more, I guess, versatile in that sense. Let me double check that real quick. Here we go. Yeah, .apply and .map on a series are interchangeable. However, .apply is a little bit more powerful because .apply will allow us to perform functions across different columns. So as an example, let's say I want to find the horsepower per weight of a car. If I want to find the horsepower per weight of the car, the function that you define should take in the entire row. That's important to remember when you're using .apply and you want to play with multiple columns. Each input into the function should be a row. So basically cardf looks like this. Let me just do the dot hid so it's not as big. If I want to take horsepower per weight, I'm just taking in a row, and a row will literally be like a row of data like this. I'm going to return horsepower divided by weight. And the way that we use this is we .apply. Here I'm doing lambda r for row, just to be easier to know what it is. And I'm just doing horsepower per weight. I'm basically broadcasting this function onto every row of cardf. And then x is equal to 1 just tells it that it's going to apply it row by row, and it's going to look for specific columns. So if I run this, oops, what did I do? Horsepower per weight is not, oh, I didn't run this yet. There we go. Okay, so now we have our horsepower per weight that returns a series. So therefore, if I want to do cardf and create a new column called horsepower per weight, I don't think that is a real thing, but if I reassign this and then take a look at car_df again, we will have this new column called horsepower per weight. Of course, you get way more complicated with this. You can even feed it in more than 2 columns if you have, a bunch of columns that you think can be engineered in a certain way that will give you a useful variable. You can definitely do that as well. So just so you know, dot apply can work on an entire data frame. And yeah, this is just really if you want to do multiple, you do an operation that takes into account multiple columns. Any questions about this? I feel like from this notebook, the maps and applies are probably going to be the methods that you will be using most. Okay, well, let's move on to the next thing. So next we're going to talk about group by. Group by has the name group by, I think, is slightly misleading because group by makes it sound like you're grouping your information, but really what you're doing is you're aggregating information within groups. So let's take a look at what group by does. Just so we remember, this is what our car_df looks like. And let's group by cylinders and just see what happens first before I explain what group by is doing. Let's just see what happens. So here what we've done, we've grouped by cylinders. Grouping by cylinders, if you take a look here, cylinders has become our new index. And then here under cylinders, we have 3, 4, 5, 6, and 8. This so happens to be the unique values of cylinders. So if we look at car_df.cylinders.value or .unique, you can see that these are our unique values from cylinders. So what this group by is doing is looking for all of the cars that have 3 cylinders, 4 cylinders, 5, 6, and 8 within each of those groups, taking the mean of those subsets. So basically, this is saying that, and let me zoom in once. Ooh, this zoom in did not work well. Anyways, so basically what has happened here is for all the cars with 3 cylinders, they have an average of 20.55 miles per gallon. Average model year of 1975.5, average origin of 3. So that's what group by is doing. We're really aggregating across unique values of a column. So going back to our explanation, to get aggregated information is about subsets of your data. Pretty much every time you use a group by, you have to pair it with an aggregation function. So let's just take away this mean. We'll see that nothing outputs because you have a generic data frame group by object. It doesn't know how to smush all of the information within like the 3, 4, 5, 6, 8 cylinders together. So that's why it's unable to return anything. Other things that you can do like a median. If you want to do a median instead of a mean, you can do that. It'll tell you that your median miles per gallon is 20.25. The median for like the heavy car, older car, whether it's Ford or not, all of these, that's there. You can pretty much do any aggregation function. And if you want to think about what is an aggregation function, if you have like a set of data, an aggregation function is usually like a single number that can represent some information about a group of data. So examples of aggregation, usually the go-tos are mean and median. There's also min, max. There's also count. So if we take a look at count will basically tell us how many cars have 3 cylinders, how many cars have 4. If you want to find like the minimum, this is a minimum miles per gallon displacement horsepower for 3, 4, 5, 6, 8 cylinders. Max will give you the maximum. All of these are known as aggregation. So whenever you're doing a group by, it's paired with an aggregation. Another example, let's take a look at group by with model year. Let's take a look at model year and let's just look at the median. So this will basically say for every model year, what all of those cars with those years aggregate to. So basically this is saying like for cars made in 1976, we have a median miles per gallon of 21. And this is really useful because in this specific example, you can see like throughout the years on average, how our cars changing, right? You can sort of see that the miles per gallon is sort of increasing over time. Number of cylinders, I don't know anything about cars, by the way. So number of cylinders looks like it's like going overall down. I don't know. Weight seems to be going lower. Acceleration seems to be getting higher. Cool. We get this information just by doing a group by a model year. So group by is extremely, extremely powerful, especially when you want to get sub-aggregated information. So yeah, group bys typically, like when you want to plot graphs about, your data here and you want to get it to be a little bit more meaningful or give it a little bit more direction, you want to do like some sort of group by first. And the result of this, you can actually save to a data frame. So let's just say we want to look at car. Let's call this car year medians. I don't know. You'll come up with better names than I will. So car year medians. Let's take a look at car year medians. Here we'll have our car year medians as a data frame. And if you want to plot this stuff, you can. So let's see, car year medians. Let's see. Let's maybe look at MPG. I always forget all the plotting functions off the top of my head. So hopefully this works. Tomorrow, we're going to talk about visualization. So cool. Yeah. Of course, you want to add like your title and all that. But just really quickly, as an inspection, you can see that model year has gone up over time. If you want to take a look at maybe weight has gone down over time. And we've done that so much more easily with the use of group by. Cool. Any questions about group bys? I will say that the concept of group by is one of those things that as people are explaining it, it sounds like, oh yeah, cool, that's easy. But then in practice, it's sometimes harder than you think. You sometimes have to think about, okay, what information do I really want? What are the subsets that I really care about? So yeah, just to keep in mind. Questions about group bys before we move on? Okay, so the next thing we're going to talk about is combining data frames. This one's actually going to be quite relevant for the upcoming project. Not the cumulative lab, but the end of phase one project. The end of phase one project, actually you're provided with 11 different tables and you have to figure out how or if you want to combine them or not. So combining data frames, there's actually several different methods to do that. Pandas has, I think, at least the ones that I'm aware of, 3 different ways to combine data frames. There is .concat, which is short for concatenate, .join, and there's another one called .merge. And they all work slightly differently. It's up to you to decide which one you like the best. I will tell you now as a spoiler, my favorite one is .merge. I've actually linked the documentation over here in case you want to read and see how it's different, but let's take a look to start. So as a really, really quick example, let's just take these 3 data frames, 1, 2, 3. Oh, by the way, something else that since we're here, if you print a data frame, it looks not as nice. If you want to do like the print equivalent of a data frame, you want to use the display syntax. So if I were to do display df1, display df2, and display df3, all in one cell, I get it to look like that. So I technically will not need these. Added bonus, for the last one, you actually never have to put a print or display because the last one by default, Jupyter Notebook will always output the very last line of whatever it is that you're doing. If that has been confusing last 30 seconds, don't worry about it. But if you want to print your data frames nicely, use display instead of print. Okay, so concat by default just puts your data frames together. So by default, if I just put a list of data frames into concat, it'll just stack them together. This is useful if you are gathering data. Let's say you're gathering data, maybe you have like one that's all data from like the 90s, one from all the 2000s, one from all the 2010s, and you just want to put them together. You can use .concat, just stack them on top of each other. You just have to make sure that the column names match. If column names don't match, Pandas will actually create a new column for every unique column name. So take note of that. So that's concat. Concat actually can work in different ways as well. So let's take a look at this new data frame. Let's try and look and see how we can join data frames 1 and 4. So one thing to note is that this is the default concat. I didn't add any other arguments to this concat. It just automatically stacks them on top of each other. Here, we're going to add a few arguments. We're going to look at inner joins and see what happens. Cool. Oh, by the way, axis equal to 1 puts them side to side. Axis equal to 0 stacks them on top of each other. So the default is axis equal to 0 to stack them on top of each other. Axis equal to 1 side by side. Let's take a look and see what happened here. I wanted to put these two data frames together. Between these two data frames, doing an inner join will only pick out the rows that exist in both data frames. So by rows, it actually looks at the index names. So here, the only two rows that are common between these two are 2 and 3. See, 2 and 3 appear in both data frames. So if I do an inner join, only 2 and 3 show up. Contrast this with an outer join. If I do an outer join, we have a lot of null values, NaN values. That's because for row 0, there is no information from here, so it has no choice but to put null values. It's important to know, like, it really depends on the context of your analysis, whether an inner or outer join is better. Do you care that you're missing like 4 other rows of data, but you have null values, or do you really only need the overlapping subsets? Those are questions that you can only answer in the context of whatever analysis that you're doing. But inner and outer joins are the main ones to know. With pd.concat, oh yeah, here I just have an example of the same example of outer join. So pd.concat does this. There are actually 4 main kinds of joins: inner and outer, which we talked about, and there's also left and right. Left and right basically do slightly different things. The only downside is, and this is why like Pandas gets a little finicky sometimes, if I look up the documentation of pd.concat, so pd.concat, if we look at the joins, pd.concat only does inner and outer joins, which for the most part usually works out fine, but let's say you want to do a left join, and I'll show you that in a little bit. You would have to look at join. So you can see here, see also dataframe.join. So dataframe.join gives you a little bit more functionality because it lets you do left, right, outer, and inner. And the default's actually left. So let's take a look at how that's different. So pd.concat, you give it a list of data frames. .join, you also have, the syntax is slightly different because instead of doing pd.join, it's df.join. So you can see I have my 1 and my 4 here. Now, this is known as the left data frame. Whichever you're joining to it is the right data frame. Let's take a look and see what happened. So when I'm doing a left join, actually, let me show an outer join first. Outer join. Okay. So outer join matches what we had here. Join is also a little bit more nuanced, I think, because you have to give it this R suffix. Let me take out this R suffix and we'll see what happened. When I take out the R suffix, it says that columns overlap, but no suffix specified. If we look at our previous join here, we actually have overlapping column names, and that can really be an issue. Because look, this B and D columns, their values are actually different. And let's say I save this as df0 as an example. Save this as df0. Cool, this is df0. If I want to pick out column B, it returns me 2 things. It can get very, very inconsistent. You run into a lot of problems with this when you get bigger and bigger data sets. So be careful about that. So that's why I like df.join, because you're forced to give it a suffix. R suffix or L suffix works. So R suffix basically says that 4 will be the suffix of any column from the right data frame. So B4 and D4 come from the right data frame. Therefore, there's a 4. You can also do L suffix too. Let's say I want to say that it's 1. There we go. So we'll have B1, D1, B4, D4, just so you can differentiate between the 2 columns with similar names. So that's really useful, but this is an outer join. Let's take a look at inner join, which should be the same thing. We have our inner join that looks like this. Left join kind of looks like it's in between. So let's look at our outer join again, just so we can compare. So a left join is just going to save all the rows from the left data frame. And then just only whatever matches from the right data frame, add that in. So that's a left join. And then a right join is kind of the opposite. You can see that the right columns are all full. The left columns are the ones that have null values. So it really depends on the data that's in your data frame. I just want you all to know that these all exist. But I think by default, the join does it left. I also want to note that these data frames are joining together based on their index column. So it's literally based on the number index, which a lot of times is not what you want to join on. So let's say you have two data frames of information about movies, which is actually sneak peek what your phase 1 project is about. Let's say you have two different data frames about movies. One data frame gives you all of the movie budgets, for example. Maybe one data frame gives you all the movies profits. So you have your budgets and your profits, and you want to do something together. Maybe you want to get your like revenue or something. So you will need to find some way to join those together. You probably don't want to join it based on the index number, because the index number is something that's just by default 0 through however many. You probably want to join it on something like maybe movie title, or if there's like a movie ID, that makes more sense. The problem with join and with concat is it only joins on its index. You would have to set a column as its index first. So let's say like just a quick example. I want to join it based on column C. So I would first have to do set index. Let's hope I remember this. I would have to set my index to be column C. So if you want to use .join, that's what you have to do first. P.merge exists, and I like merge a lot more because you can tell it exactly what column to join on. I don't want to go too into this right now. This is really up to you to experiment, but as part of the parameters, you can see that it's like left data frame dot merge right, similar to how we had it for join. It supports left, right, outer, inner, even cross join. I forget what, cross join is not relevant to us right now. But left, right, outer, inner, all supported. But you can also tell it what column specifically to join on. So if let's say we're talking about movie titles, let's say in one data frame is called title, another data frame is called movie title, you can tell it to join it on that. This will make a lot more sense when you're doing this in the context of a problem. Your topic 5 cumulative lab actually has something similar to this. So if you want to try out your joins, that's one that you can try out. But yeah, pd.merge also exists. Questions on putting data frames together at this point? All right. Okay, the last thing I want to talk about is dealing with missing data. Let's just use an example here. Very, very quick test data frame with missing data. As I showed you all yesterday, I like to use isNA.sum. So test.isNA.sum is one of my favorite ones because it shows you per column how many missing values there are. But also there's fillNA, and fillNA is a great method, I think. So let's just take a look at the documentation for fillNA real quick. I like this one in particular because they have really great examples. So here, you can replace all of your null elements with zeros, and let's actually do that. With our test data frame, when I fill everything with zeros, everything is now zeros. Cool. Another really cool one is you can fill a specific null value per column. So we could potentially do something like this. And what this is saying that I actually created a dictionary here to say, okay, for column A, fill all my nulls with 3. Column C, fill it with 2. Column F, fill it with 4. And then I fill it, I use this dictionary as a parameter in my fillNA. and it fills with specific values. This could be cool because potentially you can say, all right, I want to fill column A with the mean or median of column A, and you can do that way. So very, very neat. Where's fill in A? You can propagate your non-null values forward or backward. This is really useful if you have like temporal or like time or chronological data. This is the value one. You can also tell it how many you want to replace. So yeah, very, very useful to use the fill in A. In I think both of your cumulative lab projects, you have to do something about null values. But also wanted to show you all that this fill in A is not a destructive method, meaning if I look at my test again, oh no, our null values are still there. The last thing I want to talk about today is in place. So a lot of Pandas methods have this additional parameter called in place. So what this is it's a Boolean input, true or false. By default is false. And basically, if it's true, it will fill in place. What this means is it turns any method into a destructive method. So as you can see here, my fill in A, let's just say this fill in A did not actually carry through, like the test is still with null values. As long as I add an in place equal to true, first of all, nothing outputs. But when I look at test this time, it has my values filled. So I would usually recommend to not do in place equal to true yet until you're sure that those are the cleaning steps you want to do. And then you can maybe go back into your code and instead of like reassigning data frame after data frame, then you can switch it to in place equal to true. Just because let's just say I changed this, filled in all these null values, is like, oh no, instead of 2, I wanted this to be like the number 5 instead. It's a lot harder to go back and fix it. So I do recommend in place equals to true, good to use, but only after you're absolutely certain that that's what you want to do with your data frame. If not, I would have to go like all the way to the top or somewhere. I just have to go like at least a few cells up to get back to the data frame that I wanted before doing this step. So in place equals to true, good one to know, but it does turn your methods into destructive methods. So yeah, good to know. This is from before, so don't worry about this. So yeah, those are the main things with Pandas data cleaning. There's a lot of other things that you can do in Pandas. Again, I really want to recommend at least trying out some Pandas practice here off of this repo. Again, not made by me, made by this incredible person on the internet. A lot of good examples to just go through like full kind of like data cleaning, data analysis projects. They have a lot of solutions as well. They're well documented. So if you want to get more practice with Pandas, I will say that I would prioritize Pandas over everything else in this phase. So feel free to do that. Before I end out, kind of going off of what I just said, that Pandas is more important than everything else in this phase. The next few topics, tomorrow, instead of talking about SQL, I made a note saying instead we're going to talk about visualizations because visualizations is something that I do want to talk about in more depth than what was on the pre-work. So there's visualizations tomorrow, and then I'll get into SQL on Friday. I will also say that Friday, as well as every topic next week, is not going to be a necessary part of your project. So what that means is you can actually take it a little bit more chill next week and focus more on the project. Up to you how you want to balance that, but you don't have to incorporate anything from topics 6 through 10 into your project. So do what you want with that information. The project will pretty much end at Pandas and making visualizations out of Pandas. So yeah, I think that's good to know. So therefore, you might want to spend a little bit more time practicing Pandas because Pandas is going to be extremely important. So yeah, do with that information what you will. All right, that's all I have to share for today. Does anyone have any questions as we wrap up? Awesome. Well, if there are no questions, going once, going twice. Cool. If there are no questions, I will see you all back here tomorrow. Remember, we're going to talk about visualizations. I will get that notebook up before our study group tomorrow on our repo. And yeah, I'll see you all back here same time. Have a good rest of your day, everybody. Bye.
Oh, thank you.